Hi, my name is Farhan Ali. I'm in the differential equation class. This is our Screencast 2. Let's start off with our problem. In this question, we will draw a direction field for y prime is equal to y times y minus 1 times y minus 3, and we'll discuss the stability of the critical solutions. So what are critical points? Critical points are when we're dealing with a function of real variables, it is a point in the domain of the function where the function is not differentiable, meaning that we can't figure out what the slope is at these particular points. How can we solve for these critical points? Well, if we have our equation y prime is equal to y times y minus 1 times y minus 3, we got to find out what are the zero solutions for y prime. In this case, you can solve each one of these and determine what that could be. So I take this first one, y minus 1, I can bring this over to the other side, you get y is equal to 1. Do the same for y minus 3, y is equal to positive 3, and then y is equal to 0. So the critical points for this particular equation is going to be y is equal to 0, 1, or 3. So now we can move on to the slope field. The slope field is a graphical way for us to present the slopes of a family of solutions. So we have our y prime equation here, and then we determined our critical points were going to be 0, 1, and 3. I placed them on this number line here, and I got infinities on the edges here, negative infinity to infinity. And these are our 4 intervals. I first started by creating a table of values, and I just picked a number line within each of those intervals to determine what the slope could be. And then we can study the behavior of these slopes. So when y was negative 1, our slope was negative 8. When I had 0.5, our slope was positive 0.625. And then y is equal to 2, I got y prime is equal to negative 2, 4, and 12. So if you notice, when it's from 0 to negative infinity, it's negative. This function is decreasing. And then from 0 to 1, it's positive. This function is increasing. So if I put in any values from here, you'll see that it'll remain positive. The slope will remain positive. And then if I come down here, I can plot this with x and y. You can pick any x value that you'd like, and we will get a slope. And you'll see at the critical points, you'll get horizontal lines because it's undefined. We don't know what's going on at those points. But anywhere else, if I take like negative 1 and I come over here, let's just say x is negative 1, it's going to be a negative slope right there. And then we can use a slope field plotter, and you can see the slope for this equation. I went ahead and multiplied it all together here. And you can see that we get a horizontal slopes on 3, 1, and on 0. And then everywhere else you can see, I think it was right here, it was negative, and then it becomes, I'm not getting the step here, but it should be positive here, and then negative, and then back to positive up here. 3 to infinity. And then if I were to plot the same equation onto Desmos, you can get the graphical solution. So we can see where it crosses the x-axis. I had to label it as x for this, otherwise the graph was sideways. But if these are all y's, this would be the y-axis. And you can see where it crosses this axis here, 0, 1, and 3. Those are our 0 solutions. We don't know what's happening at these points if we couldn't see this graph. And we can see that using this graph, though, you can see that below 0, it's going to be all negative, going all the way down. And then from 0 to 1, it's all positive. And then from 1 to 3, it's in the negative region. And then from 3, it's all positive. Okay. Yeah, the slopes are negative, slopes are positive, and then slopes are back to negative, slopes are positive. Okay, just double checking my work. And then to check for stability, you can see I had the number line and I had 0, 1, and 3. I had that the function was decreasing, so it's moving away from the value. It was increasing, so it's moving away from 0, but it was moving towards 1. And then this one is negative, it's moving towards 1. And then after 3, it's moving away again, it's positive. It's diverging. So at 0, it's diverging. At 1, it's converging. And then at 3, it's diverging. And that right there tells you the stability, that at 0, it's unstable because both of these are diverging on either side. And at 1, it's stable, it's converging to that value 1. And then 3 is diverging and it becomes unstable because it's moving away from the critical point. And then I plotted this here in relation to t. As t approaches infinity, you can see that these values are diverging. And then the same thing happens here. They're converging to 1. And then from 0 to 1, it's convergent to the 1, but divergent from the 0. And then from 0 to negative infinity, it's divergent towards infinity. Okay. Okay, so in short, when we had the y prime function, we can determine the critical points. With the critical points, we can determine the behavior of the graph by picking any arbitrary number within each of those intervals, and we can find out what's happening on those intervals, whether it's negative or positive, which is another way of saying decreasing or increasing in slope. And then by having all of these combined, we can get the combination pattern to find out if they're converging or diverging. And that will tell us if it's unstable or stable. Okay. Thank you very much. I know this video was very crude, but it was kind of very hard for me to explain this in words.